Hi again. So today I'm going to be sharing my current research project, which is artificial intelligence-powered smart cities. So currently we are focusing specifically on electric vehicle adoption because it represents a crucial element in the transition towards sustainable urban living, and artificial intelligence can also play a key role in addressing some of the challenges faced with electric vehicle adoption. This research is through a directed individual study with Professor Guang Wang in the Department of Computer Science, and currently we are still in the beginning stages of this research project, so today I will just be sharing the findings of my literature review, our survey design, and our future goals for this project. I conducted a literature review about the drivers and barriers for electric vehicle adoption in rural and urban communities, and today I'll be sharing some of the key details about adoption in rural communities, as I think it is more significant since they encounter a greater number of barriers for electric vehicle adoption. So the main drivers for electric vehicle adoption in rural communities are government, financial incentives, savings on fuel maintenance, and new economic development. The main barriers for electric vehicle adoption in rural communities are range anxiety, high costs, and installing and maintaining charging stations. The United States and several other countries around the world offer many financial incentives for purchasing electric vehicles, some of which are rebates and tax deductions such as electricity discounts. In addition, some countries are not only offering tax relief, but are also offering free toll exemption, free parking, and free charging stations, which is a huge driver for adoption. Also, while electric vehicles typically have a high upfront cost, they are proven to have a lower total cost of ownership when compared to conventional vehicles, which is due to lower fuel maintenance costs, which is another very important driver. However, range anxiety is the biggest barrier for electric vehicle adoption in rural communities. It is essentially anxiety surrounding how far electric vehicles can travel without running out of battery. This is especially significant because there are very few charging infrastructure in rural communities, and since rural areas are more reliant on personal vehicles due to the lack of public transportation. The unavailability of adequate charging infrastructure is one of the biggest constraints for electric vehicle adoption in rural areas. Rural areas are also characterized by lower household income, which by definition means that they also have less disposable income. This makes rural households very sensitive to the high upfront costs that are often associated with purchasing electric vehicles. So our next step in our research project is conducting a survey questionnaire in which we are using a conjoint experiment. We chose to use a conjoint experiment since it allows us to understand the trade-offs that consumers are willing to make when considering purchasing electric vehicles. The introduction for our survey is as follows. The range of travel for a new typical electric vehicle is 250 to 300 miles before it needs to be recharged, and the cost of an electric vehicle is usually $10,000 to $12,000 more when compared to a gasoline vehicle. Both foreign and domestic automobile manufacturers sell electric vehicles, which now account for about 15% of new car sales in the United States. Charging an electric vehicle is about 3 times cheaper per mile than fueling a gas-powered vehicle. Many areas have places where you can recharge an electric vehicle, and this usually takes less than 1 hour. However, rural areas often do not have easily accessible charging stations. In this survey, we will be testing multiple scenarios in order to see which factors are the most relevant when considering purchasing an electric vehicle. We will mainly be testing different policy tools, policy funding, and social norms to understand the key factors that motivate or deter the adoption of electric vehicles. We have also been doing some data analysis and data visualizations from some previous census tract data that we already have. The main significant visualizations and statistics that we have found are charging station distributions, chargers distribution, charging accessibility, and different socioeconomic features to investigate what features will impact people's motivations to buy electric vehicles. We also have some visualizations and statistics about electric vehicle registrations in each region of Florida. So with the future of this project, we aim to essentially use our survey results to draw some conclusions about the adoption of electric vehicles in rural and urban communities. From there, we would like to make a machine learning model to solve one of the barriers with the adoption of electric vehicles. We would like to make a machine learning model to predict where charging stations will be most needed and used in rural communities based on various data points such as travel patterns, vehicle registrations, and geographical information. We would do this using some of the data from our survey results and several other large data sets to identify correlations that can be used when making infrastructure for charging electric vehicles. Therefore, we would use this model to strategically find locations where charging stations would maximize accessibility and convenience for electric vehicle drivers and to encourage the adoption of electric vehicles. So thank you so much.